Hi everyone, this is Mrs. Tukino, and today I want to review with you slope from an equation, graph, and a table. I want to start by beginning with what is slope. So slope is defined as the measure of steepness of a line. It is the ratio of the change in the values on the y-axis over the change in the values of the x-axis. Remember, the y-axis runs up and down, and the x-axis runs left and right. You will often see slope written as the rise over run. So rise is our change in our vertical, which is our y, and our run is our change in our horizontal, which runs left and right. Slope can be positive, it can be negative, it can be zero or undefined. We're going to talk about all of those in a little bit. But if you've ever walked up or down a hill, then you've already experienced a real life example of slope. You know, the steeper up the hill, the harder it is for you to keep yourself moving. And we call that positive slope. Just the opposite is true of going downhill. The steeper the downhill slope, the easier it can be to keep yourself moving. And that would be a negative slope. So let's take a look at positive slope. Positive slope is when we read from left to right. And it's really important that you guys remember that when we read graphs in math, we always want to read them from left going to our right. And we want to find out what is happening from the left to the right. So in this case, as our y values are increasing, our x values are increasing. So as I move over to the right, I can see that my y values are moving in an upward direction. So that would be a positive slope. All right, let's talk about negative slope. Negative slope is just the opposite. In this case, as we read this graph from left to right, we can see that as our x values are increasing, or as our x values are moving over, our y values are going down. So then we would say that this would be a negative slope. All right, let's talk about a slope of 0. Slope of 0 is, I like to say, kind of an easy, nice walk in the park. So it's the line is going to run horizontal. The y values are not changing at all. As you see in this graph, there is no up or down movement in this line. It is staying right along the x-axis. So the y values are not changing at all as the x values are increasing. So as I read this graph from left to right, I can clearly see that as the x values increase, the y has 0 or no change. All right, what about undefined slope? This one's really important, and I'm going to take a little bit of time to kind of discuss this concept of undefined slope. Undefined slope will be a vertical line. It will run up and down. So the y values are changing, but there is no change in our x values. So I have no change going left and right. This is simply a line running straight up and straight down. So why do we call it undefined? Well, let's talk about what it means to be undefined. So in order to do this, I want to go back to 3rd grade when we learned how to multiply and divide. So we first talked about multiplication, and then we talked about division and how division undid multiplication. So let's take a look at a very simple example. If I had something like 6 divided by 2, many of you out there are now saying the answer is 3. And I'm sure the answer is 3. But remember back in the day when you had your 3rd grade teacher and they said, well, let's go back and let's check. How do I know that that is correct? Is there something I can do that I already know that might help me with my division facts? Well, one of the things that teachers would have said would be, why don't we try to undo what we just did? So that if I worked backwards and I said, well, what is 3 times 2? Does that get me back to 6? And if your answer is yes, that means your division was done correctly. Okay, that makes sense. So let's think about that in this form of undefined slope. We talked about, again, remember, slope was the change in your y over the change in your x. So I'm going to write that as delta y over delta x. And if we think about it, this change in our y, the y is always changing. So whatever our y value is, it is changing. But we said we had no change at all in our x going in this direction. So if we have no change in our x, that means we have 0 in our x. So let's talk about what happens when I divide by 0. Well, let's take the same concept. What if our y was 6? Okay, so if our y is 6, let's take a look and let's write that. 6 divided by 0. What does that equal? Now, many kids will say, well, 6 divided by 0 is 0. Well, let's think about that for a second by using the same method we did up top. If 6 divided by 0 is 0, to check that, we would say, okay, well then 0 times 0 must equal 6. Wait a second. We know that's not true. So therefore, that's why we say this is undefined. We cannot do this. We cannot divide by 0 and get an answer that's going to be anything in the real number system. So when we have no change or we have a 0 change in our x, we're not going left and right at all, and we have a denominator of 0, we call this undefined. I'm going to abbreviate that by writing undefined. All right, let's talk about slope-intercept form. Slope-intercept form is typically written y equals mx plus b, where the m is going to be our slope, and this plus b, or it might be minus, it might be plus and negative, however we want to write that, this is going to be our y-intercept. Now, this can be kind of hard to understand, so I decided to pull an actual example to maybe hopefully make some sense out of this. So there is a Planet Fitness in North Brunswick, and I wanted to see what it would cost to join this membership. So this is what was posted on their website. I just took a clip of what it was. So I wanted to try to figure out how we put that into this equation and think about what this equation is actually doing. So we know that the slope is the change over in our x. So I know our slope is how is it changing from our left to our right? What's going on here? So in this case, the change here every month is going to be the monthly fee. So the monthly fee here is $22.99. So I know that my total cost, so if I'm going to be dealing with my total cost, and that's what I want to try to find here, my total cost that I've spent on this gym membership will be the $22.99 per month that I keep this membership going. But I also have to pay this initial this annual fee of $39. So just to join this gym, they're going to make me pay $39 and then $22.99 a month after that. So my first month, I have to pay $22.99 plus the $39. The second month, I pay $22.99. That would be times 2. So 2 months would be $22.99 times 2. But I still had that initial $39 fee. I don't have to pay it one time once every year. So that's how this situation would be placed into this equation, where my y-intercept would be when x is 0, or when I don't have a month down at all, I still had to pay the $39. In order for my first month, then I'd pay the $22.99. A second month, I'd pay another $22.99. But again, I would still have that initial $39 annual fee. All right, let's take a look at some examples of slope. The first one's going to be very simple. Oops, sorry. The first one's going to be just simple. It's going to be y equals 2x plus 5. So this is written very nicely in slope-intercept form in the way that we initially just saw it in the previous slide. So in this case, I automatically know that my x value, my coefficient of x, is going to be my slope. So in this case, my slope here is going to be 2. Now remember, the slope also be written as 2 over 1. We just, mathematics, if you have a whole number and it's being divided by 1, we know the answer is 2. But just remember that that is a rise of 2 and a run of 1. Okay? And then that would be our m, I'm sorry. And then our y-intercept, or our b, is going to simply be what happens, what is y when x is 0. So our y-intercept is always going to be what is our y when x is 0. So if I was going to rewrite this equation and say, okay, what is y equal to when x is 0? It's easy to see now that 2 times 0 is 0. And then I have y is equal to 0 plus 5. So my y is equal to 5. And so right here is my y-intercept. My y-intercept is 5 because when x is 0, all I'm left with is plus 5. Okay, let's take a look at the next example. This one's written a little differently, but remember, an equation is just balanced. So I happen to have the y on the right-hand side of this balance beam, but it doesn't really matter because all I am looking for is I'm trying to identify what is my coefficient of x, because I know that that is my change, and then where is this equation starting? So let's take a look at what happens when I try to identify my slope here. Well, I know that my slope is now -3. And then what is my y-intercept? Well, what happens when x is 0 there? So my y-intercept, I should put my b here, is going to be equal to what happens when x is 0. So if this was -3 times 0 is 0 plus 5 is equal to y, well, then y must equal 5. So in this situation, my slope is -3. And again, we could say that's -3 over 1 or -3. Make sure that you understand that that's down 3 over 1. And that my y-intercept would be at a positive 5. All right, the next equation. This one's written, again, a little bit different, but I just want you to keep identifying where we can find the slope and the y-intercept. And in this situation here, we have our x value. So we know right now that our change here, our slope is going to be changed here. It's 2 over 1 again, just like the first one. And then again, what happens when this is 0? When x is 0, we have 2 times 0 is going to be 0, and we have a -5 is remaining. So that means our slope is going to be 2, and our y-intercept in this case is a -5. So this line will pass through the y-axis at -5. All right, another one, y is equal to 4/5 x. And in this case, again, we have a slope that's easily identifiable because it is in the coefficient of x. So I know that in this case, my slope is going to be 4/5. But now what's my y-intercept? Well, again, I want you to have the same concept that we did before. What happens when x is 0? If y is equal to 4/5 times 0, then y must equal 0. So my y-intercept is really 0. And so when we don't have this plus something else here, I think everyone always wants some kind of like a plus 0 here. Mathematicians, we don't want to write things that we don't need to write. And so we don't need to write the plus 0. We just have to understand that when x is 0, that y will also be 0 in this case. So you will often see that the equation, when they don't have a plus or minus after it, we just understand the y-intercept is just going to be 0. Okay, and our last one, y is equal to x. Well, this one looks really funny, but it's no different than all the other ones that we've been talking about. If y is equal to x, that means whatever y is, x also must be. So what is the slope of that line? Well, what is the coefficient of x? Well, we know that the coefficient of x, when it's not there, means 1x. I want 1 of that thing. So our slope in this equation is going to be 1. And then what is our y-intercept? Well, what happens when x is 0? Well, when x is 0, guess what? Y is also 0. 1 times 0 is 0. Y would equal 0. So this graph would also have a y-intercept of 0. All right, let's take a look at finding a slope from a graph. So if we take a look at this graph, I want you to go back to what I said at the very beginning, is that we always want to be entering our graph from the left to the right. So I'm going to enter this graph from the left and move to my right. As I enter from left to right, I want to say what is happening to this line. So I know some of you that I was working with before, I said, imagine, yourself or me, I always like to think of myself, on a skateboard. So here I am entering in on a skateboard from the left to the right. So I'm entering in and I'm touching the line. And clearly you can see that I am going to have to move in an upward direction on my skateboard here. So that means that this is going to have a positive slope. So I want to remember the way that those lines looked. We had a positive slope runs up, the negative slope runs down, a zero slope runs left to right on a horizontal line, and the undefined one that was dividing by zero is running up and down on that vertical line. So how do I calculate the slope? Just by looking at this graph. Well, remember, slope is always, as Ms. Skelton said, it's going to be your delta or your change in y over your change in x. So how is my y value changing? Well, if I take a look at this line, I am clearly moving up to, maybe I should pull a different color again here. Let me pull out a green. Let's see, up to, and I'm moving over 1. And I can see that change in the points given. I know that here I went from 3 to 5, so that is up to. And I know I went from 0 to 1, which is over 1. So my slope for this equation, I could simplify that and say my slope is a positive 2. What is my y-intercept? Let me get back my slope of 2 here. What is my y-intercept? Well, what happens when x is 0? So when x is 0 on my graph, where is my y point? Well, where it crosses the y-intercept here is going to be at 3. So my y-intercept here is a positive 3. So this is a slope of 2 and a y-intercept of positive 3. Take a look at another example. And again, I want to remember my types of slope. And again, I'm going to be entering this graph from the left to the right. So here I am again on my little skateboard. I need to draw a skateboard better. But as you can see, if I enter left to right on a skateboard, I am moving in a downward direction, which means I have a negative slope. So before I even start doing anything, I can automatically put that negative sign there because looking at this graph, I can see that I'm moving in a downward direction or I'm going to have a negative slope. All right, so let's take a look. Well, how far down am I going? This one doesn't have any points, but we don't need them. We can just look at our graph itself and start counting. So I'm going to start at this point right here, and I'm going to go down 1, 2, 3. So I know I went down 3. Well, how far over did I go? Well, I went over 1, 2, 3, 4. So simply, my slope is down 3 over 4. I can't simplify that, so my slope is going to be negative 3/4. All right, now what's my y-intercept? What is that b? Well, what happens when x is 0? So when I'm right here at 0, where am I crossing this line? And clearly we can see that my line will cross, as I'm sliding down on my skateboard, my line will cross at 5. Positive 5. So my y-intercept is 5. When x is 0, y is 5. All right, let's take a look at this graph. This graph, again, as we can take a look at our types of slope, we can see that this is going to have a 0 slope. This is actually the graph of the equation y is equal to 3. And so let's take a look at what's going on here. Again, let's remember what Ms. Skelton said. We have a change or a delta y over change in x. So let's take a look at our y values. We'll look at all of our y values. Are they changing? They are not. They went from 3 to 3 to 3 to 3. So the change in y is 0. What is the change in x? It really doesn't matter what our change in x is because when I take 0 and divide it by any number, let's say the change is from here to here, that was a positive 2. 0 divided by 2 is simply 0. Now I can check that with my 3rd grade math by writing it in this way. 0, sorry, my pen turned off. 0 divided by 2 is equal to 0. Is this a true statement? Let's work in reverse. Is 0 times 2 0? Yes, it is. So therefore, we know our slope is a 0 slope. It is equal to 0. So in this case, my m is 0. And now what is my y-intercept? Well, it intercepts when x is 0. It's going to intercept right here at 3. So my y-intercept in this situation is going to be 3. It intercepts my y at 3. Okay, last one. What happens with this one? Well, again, let's take a look at our types of slope. We see this one as being undefined, and we talked about this one. But if you take a look at why or where this one is, we can see that there is no change in our x. So when I want to write what is my change in x, I know that my y can change by whatever it wants to change by. But when I divide by 0, I know that that's going to become undefined. So this has an undefined slope. So let's talk about, what about our y-intercept? Well, if we take a look at our y-intercept, I can clearly see this is not intercepting y anywhere. So there is no y-intercept. And there really is only one case where we really can identify a y-intercept. And if we think about what happened if I had my line here, well, my y-intercept would be infinite. I would have an infinite amount of points intercepting. So in this case, there is no, it's an undefined or no intercept at all, I should say. There's just no y-intercept in any of these cases, because no matter if it's right on that y-axis, then I have an infinite amount of intercepts, and I cannot identify one y-intercept. All right, let's talk about finding slope from a table. And I want to revisit this little graph at the little image at the bottom. And remember, it is our vertical change over our horizontal change, or our rise over our run. So it's our change in our y's going up and down over the change in our x's. So let's take a look at a table. So this table is talking about time and distance. So let's take a look. This is going to be, time is always going to be your x-axis, and your distance is going to be, in this case, your y-axis. Okay, we talked a little bit about that before, about your dependent and independent. So your your time is always going to be on that x-axis. So let's take a look at how distance is changing. So distance-wise, I am, in this case, every time I move up here, I am adding, and this just because I threw a decimal in here, just because, but this is not that complicated. 6.5 plus another 6.5 is going to give us 13. So every step of the way here, I am increasing by 6.5. So my change in my y, which is my distance, is going to be a positive 6.5. Now, what is my change in my x? Let's take a look at our change in our x. So I go from 0 to 1, which is up 1. I go from 1 to 2, which is up 1. I go from 3 to 4, which is up 1. And as you can see, all of these are going to be a plus 1. So if I want to do my slope from this table, my slope is going to be, m is equal to 6.5 over 1, or 6.5. What's the y-intercept? Remember, I said y-intercept is what happens when x is 0. Well, I have that right here on my in my table. Here is x is 0. What happens when x is 0? Y is also 0. So my y-intercept is 0. So when I'm looking at a table, I just need to merely find my 0. Sometimes I'm going to have to calculate it, but in this table, I actually can see my 0 for my x, and I find my y. All right, let's take a look at this next table. So this is an older table, number of Nintendo games rented, but I just wanted to show you that sometimes we had, rental services before where you could, pay a fee and rent some games. So in this case, the total cost of number of Nintendo games rented would be the x. Sorry, let me get a darker color here so you can see it. This is going to be my x values, and the total cost is going to be my y. Y is typically noted as our total that we're going to pay. So what is happening? What is my change in y? Well, I went from 20 to 30, which is plus $10. I went from 30 to 40, which is plus $10. I went from 40 to 50, which is plus $10. And this is going 50 to 60 and 60 to 70. So clearly my change in my y is going to be 10, positive. What is my change in my x? Well, I went from 0 to 5, which is 5, plus 5 to 10, which is plus 5. Oops, sorry. And then 10 to 15 is plus 5, and 15 to 20 is plus 5, and 20 to 25 is plus 5. So I know that I have a plus 5. Now, I have a change in my y over my change in my x, but I can simplify this ratio. So I do know that 10 can be divided by 5. And so I know that my simplified version of this, if I divide both by 5, I would end up with 2 over 1, or simply a slope of 2. Okay? So in this case, my m is going to equal 2. Now, what is my y-intercept? Well, remember, y-intercept was what happens when x is 0. Well, here is x is 0 right here. What happens when x is 0? Y is $20. So my y-intercept is going to be 20, or $20 in this case. We need to make sure that when we write slopes, when we're finding our slope, we find it from a table, we find it from a graph, that we want to simplify those ratios to the simplest form of slope that we can. Sometimes that's going to take and become a whole number, and sometimes it just becomes a simplified ratio, which sometimes we like to call a fraction. But I just want you to understand that slope is not a fraction. It's a ratio. It's a comparison of two things happening. The y-intercept of a vertical line, remember, a vertical line is a line that runs up and down. And when we have a line running up and down, there is no y-intercept in these vertical lines. So we would just say there is no y-intercept in that vertical line. It is an undefined slope and no intercept. What is the y-intercept of a horizontal line? The y-intercept of a horizontal line is going to be the point at which this line touches that y-axis. So that one we can identify. So you can identify the y-intercept of a horizontal line. You cannot of a vertical line. So we can think of that as when I have 0 slope, when I'm just taking that nice stroll in the park, I just have to find where that line crosses that y-axis. All right, so hopefully you guys can rewatch this. I don't have any assignment or homework aside from watching this for you. If you would like to ask me any questions, I'm going to be putting a form in that you can ask me some questions on the form, and I can try to get back to you. But I hope this has helped you a little bit, and good luck doing your work.